how many times more intense is the sound of a referee's whistle at 125 decibels than a train whistle at 200 meters at 90 decibels? Answer to the nearest whole number. So we have two concepts here. We have the concept of decibel, which refers to the loudness of the sound, and we have the concept of sound intensity, so sound intensity is measured in watts per meters squared, and loudness is measured in decibels. There is a formula that connects these two concepts, and it looks as follows. So we have loudness in decibels we're going to refer to loudness by beta equals to 10 times the log of the sound intensity I divided by I naught. Okay, so here I in the numerator refers to the sound intensity. In watts per meters squared. The I naught in the denominator is a constant. I naught equals 10 to the power of negative 2 watts per meters squared, and it is the faintest audible sound. So faintest audible sound intensity. So we want to determine how many times more intense the referee whistle is over the train whistle. So what we're going to have to do here is we're going to have to divide the sound intensity of the referee whistle. We're going to refer to that as I sub R. Divide that by the sound intensity of the train whistle, I sub T. And this here is going to give us how many times more intense the sound of a referee's whistle is than a train whistle. So what we have to do here is we have to use this formula and determine the sound intensity, the capital I in the numerator here, for the referee's whistle and the train whistle, and then we're going to divide them like this. Okay, so let's start with the referee's whistle here. So we have the loudness is 125 decibels, and that equals to 10 times log of the sound intensity divided by this constant 10 to the power of negative 12, like that. And so now we need to find an expression for the sound intensity. So actually, because this is the referee's whistle, we're going to call it I sub R. For the train whistle, it's going to be 90 decibels equals to 10 times log I T divided by 10 to the power of negative 12. So the first step in both of these equations here would be we want to isolate the intensity, so we can divide both sides by 10 to get rid of this constant here. So here we're going to get 12.5 equals log of the intensity over the constant. We're going to do the same thing here. Divide both sides by 10. We're going to get 9 equals to log of the sound intensity over 10 to the power of negative 12. Okay. So what we need to do here is to isolate or to solve it for the intensity. We're going to convert these two log expressions to exponential form. So in both cases, the base of the log is 10. That means that the base of the exponential form is going to be 10 to the power of 12.5 equals to the argument of the log equals to sound intensity divided by 10 to the power of negative 12. So we have converted from logarithmic form to exponential form so that we can get to the sound intensity. We want to be able to isolate that so we can divide them here. We're going to do the same thing down here. The base is 10. The exponent is going to be 9 equals to the argument of the log like that. And now we can isolate the sound intensity, multiply both sides by the constant. So we're going to get I sub r equals 10 to the power of negative 12 times 10 to the power of 12.5. Sound intensity of the train equals 10 to the power of negative 12 times 10 to the power of 9. So now we have our sound expressions, at least for the sound intensities of the referee's whistle and the train. Now we're going to divide it like this to find out how many times more intense is the sound of the referee's whistle compared to the train whistle. So it's going to be IR, which is 10 to the power of negative 12 times 10 to the power of 12.5 divided by 10 to the power of negative 12 times 10 to the power of 9. And here we can see that the 10 to the power of negative 12, those two factors will cancel out. And then we can see that we can actually apply the quotient law, the exponent law here, quotient law. To simplify this, we have two powers with the same base, which means that we are going to subtract the exponents because it's a quotient. So we're going to get 10 to the power of 12.5 minus 9, which is going to be 10 to the power of 3.5. So that's the answer. This tells us that the referee's whistle is 10 to the power of 3.5 times more intense than the sound from the referee's from the train whistle. Now they want the answer in decimal form, I believe. Yeah, they want the answer to nearest whole number. So we can just evaluate this on our calculator, and if we do that, we're going to get 3,162.